Ever wondered how one man could reshape the landscape of mathematics and science? As we delve into history, we come across such enigmatic figures, a prime example being Jules-Henri Poincaré. This French polymath was not just a mathematician, but also an engineer and a theoretical physicist. His broad spectrum of work touched upon various fields, leaving a lasting influence that continues to resonate to this day. He's the man behind the Poincaré Conjecture, a cornerstone of topology. He delved into the complexities of celestial mechanics, investigating the infamous three-body problem. His contributions to mathematical analysis, his insights into mathematical intuition, and his thoughts on scientific methodology have all shaped the way we perceive these disciplines today. He was also a prolific writer, whose correspondence and collaborations with other mathematicians of his time provide a fascinating insight into the world of late 19th and early 20th century academia. Join us as we delve into the extraordinary life and work of Jules-Henri Poincaré. Born in 1854, Poincaré's journey into the mathematical realm started early. He was born in the beautiful city of Nancy, France, into an influential family that nurtured his intellectual curiosity. His father, a professor of medicine, and his mother, a passionate lover of literature, fostered Poincaré's love for learning. Poincaré was a prodigious student, and his brilliance became evident in his early school years. His fascination with mathematics was kindled by his school mathematics teacher, Monsieur Serre, who introduced him to the intriguing world of numbers. Poincaré's genius was further honed at the prestigious École Polytechnique, where he delved deeper into the complexities of mathematics and physics. Graduating at the top of his class, he went on to join the renowned École des Mines, pursuing a career in mining engineering. However, his heart was always in mathematics, and it was during these formative years that he began developing his groundbreaking mathematical theories. These early experiences set the stage for Poincaré's monumental career. In 1904, Poincaré posed a question that would puzzle mathematicians for a century. This question, known as the Poincaré Conjecture, is a landmark in the field of topology, the study of properties that remain unchanged under deformation. The conjecture is deceptively simple, stating that any shape that doesn't have any holes and fits within a finite space can be stretched and deformed into a sphere. It's like a donut and a coffee cup being the same in the world of topology, as you can morph one into another without tearing or gluing. But proving this conjecture was anything but simple. In fact, it remained unproven for over a century, baffling some of the greatest minds in mathematics. It wasn't until 2002 that Russian mathematician Grigory Perelman provided a proof, earning him the highest honor in mathematics, the Fields Medal. This conjecture, proven over 100 years later, remains a testament to Poincaré's foresight and brilliance. Poincaré's influence reached far beyond topology. His contributions to celestial mechanics, particularly the three-body problem, and his work in mathematical analysis are noteworthy. In the realm of celestial mechanics, Poincaré tackled the three-body problem, a conundrum that has perplexed mathematicians and astronomers for centuries. This problem involves predicting the motion of three celestial bodies interacting with each other through gravitational attraction. It might sound simple, but it's anything but that. Poincaré's approach was innovative. He didn't search for a precise solution, but rather sought to understand the nature of possible solutions. This shift in perspective led to the development of new mathematical techniques and the foundation of chaos theory. This is a prime example of Poincaré's genius, demonstrating his ability to see the broader picture, to connect seemingly unrelated areas of mathematics, and to forge new paths in the process. Moving on to his contributions to mathematical analysis, Poincaré's work was vast. One of his significant contributions was on automorphic functions, a class of functions that arise in complex analysis and number theory. His work on these functions laid the groundwork for a more profound understanding of the structure of mathematical objects, a theme that would recur throughout his career. Poincaré's work in mathematical analysis also included groundbreaking research in the field of differential equations. His methods are still used today in various fields from physics to engineering, demonstrating the far-reaching impact of his ideas. In both celestial mechanics and mathematical analysis, Poincaré showed an impressive ability to interweave different mathematical disciplines. He didn't see mathematics as a collection of isolated topics but as a web of interconnected ideas. This holistic vision led him to insights that transcend the boundaries of individual mathematical fields. Through these works, Poincaré demonstrated a remarkable ability to interweave different mathematical disciplines. Poincaré was not just a mathematician, but a philosopher and a collaborator. His curious mind delved into the depths of science, questioning the very fabric of our understanding. He believed in the philosophy of science, that it was not merely a collection of facts, but a synthesis of ideas. Poincaré asserted that science's true purpose is to simplify as well as to unify, to colligate seemingly disparate phenomena into a coherent and logical system. Poincaré's insights into mathematical intuition were profound and insightful. He contended that mathematics is not merely a dry pursuit of numbers and equations, but a creative discipline that springs from the human mind. For him, intuition was a kind of instinct, a mental shortcut that bypasses laborious calculation and leaps straight to the heart of a problem. He believed that these intuitive leaps, these flashes of insight, were at the heart of mathematical discovery. In his view, mathematical intuition was not just about immediate perception, but also involved a deeper subconscious process. It's as if the mind is an internal workshop, silently toiling away even when we're not consciously thinking. And then, in a moment of revelation, the solution emerges, fully formed, into our conscious mind. This process, he argued, was the essence of creativity in mathematics. But Poincaré was not a solitary genius. He was a collaborator, working closely with other mathematicians of his time. He corresponded with many of the great minds of his era, exchanging ideas, challenging assumptions, and pushing the boundaries of mathematical understanding. He believed in the power of many minds working together, that collaboration was the key to unlocking new mathematical truths. Poincaré's approach to mathematics was holistic, integrating philosophy, intuition, and collaboration. He saw mathematics not as a collection of separate disciplines but as a unified whole, a grand tapestry where every thread is interconnected. His insights into the nature of mathematical thought and the process of discovery have deeply influenced how we understand and practice mathematics today. Poincaré's holistic view of mathematics continues to inspire scholars across disciplines. His legacy is not just in his mathematical achievements, but in his philosophical insights and his enduring belief in the power of collaboration. Poincaré's influence did not end with his death in 1912. Quite the contrary, his prolific publications and groundbreaking theories continue to shape the fields of mathematics and science to this very day. A polymath in the truest sense, his work transcended boundaries, inspiring generations of thinkers across various disciplines. A testament to Poincaré's brilliance can be found in his extensive writings. He authored over 500 books and papers during his lifetime, on subjects as diverse as number theory, celestial mechanics, quantum physics, and philosophy. These publications, teeming with insight and creativity, have become foundational texts in their respective fields. Poincaré was not merely a mathematician or a physicist, he was a visionary who dared to explore the uncharted territories of knowledge. Equally impressive is the fact that Poincaré's theories continue to hold relevance in contemporary research. His conjecture, once deemed an insurmountable puzzle, was proven correct nearly a century after its proposition, affirming his genius and foresight. His work on the three-body problem still forms the basis of our understanding of chaotic systems. His ideas on automorphic functions and mathematical analysis have found applications in modern fields like quantum mechanics and string theory. But perhaps Poincaré's most enduring legacy resides not in his specific theories or discoveries, but in the profound influence he had on the philosophical underpinnings of science. He fervently believed in the beauty and elegance of mathematical truth, insisting that intuition and creativity were as essential to scientific discovery as rigorous logic. This belief, powerfully expressed in his writings, has shaped the way we approach and perceive the world of mathematics. Beyond his academic contributions, Poincaré's life and work serve as a reminder of the power of curiosity, the thrill of discovery, and the limitless potential of the human mind. His legacy is a testament to the idea that science and mathematics are not merely tools for understanding the universe but are, in themselves, a form of artistry, a celebration of the human spirit's capacity for wonder and exploration. Through his life and work, Jules Henri Poincaré forever changed the way we understand the mathematical world.